Hi there, and you're very welcome to our 7th episode of the Science Lesson Support System, suitable for primary school age 6 and all the way up to secondary and right through to long life learners. In our last episode we covered magnetism and how these simple little resources can help add connectivity to all of your existing science lesson plans. Today we'll be covering hot and cold things and how it integrates into all other topics and areas through overlapping laws of nature. So let's get started. Hot and cold things falls under the field called thermodynamics. To make thermodynamics easy, it could be looked at in two main ways. One is balance or equilibrium, meaning the temperature of all objects always try to meet somewhere in the middle. But this is a restless world. Energy is always added into the mix, creating the differences in temperatures and fluctuations that we see every day. The other one is that hot stuff always naturally flows to cold stuff, unless energy is added to force it up the other way. It's just like water will always naturally flow down a mountain, but if we add energy and work, we can pump water back up the mountain. As we covered in our solids, liquids and gases section, everything we can see, smell, touch or feel is made of atoms, including us. And these atoms and molecules allow us to interact with things that you can't directly feel or touch. And one of those things is heat. But in essence, here is how we will be learning about it today. Hot things in matter means molecules, atoms and bonds jiggling and dancing. It's that simple. That's your takeaway. Add more heat and they jiggle and dance faster. But if we keep turning up that temperature and up that heat, we begin to break their bonds physically and change the material state of matter. In other words, we can turn solids and melt them into liquids, and we can turn liquids then and turn them into gases. Although solid surfaces, when they feel hot, we can't see any of this heat. But when we melt something, it can start to glow. This is the atoms and molecules shaking so hard they're giving off the energy in the form of light. Okay, let's make our forever resource and try articulate this jiggling of our atoms. For better integration into our solid structure, we'll make our jiggly heat out of carbon. So what we're going to need is just one carbon atom, one spring, and in order to help the spring glue to the carbon atom and make life a little bit easier, we're going to use 3 electrons as stands, but we'll be removing these when we're finished. There are various different springs you can get and different sizes, but you want one that has a really springy spring in it. Just remember that the springs are representing your electron bonds. Apply 3 temporary connectors as stands, and we will remove these when we're finished. Apply a liberal amount of glue and apply the spring and give it a little bit of a twist. Then stand it up and let it dry. Now that our bottom row is dried, we'll now remove all of the legs. Pop a little pencil down for support. Apply your glue to the top row of atoms and just simply connect, twist the spring, sit down on the pencil and just rotate your holes to make sure they're pointing in the same direction. You should be able to let it go now and it should dry. Don't be afraid to give an extra little bit of glue forced in through the spring to get a really good solid hold. Now that we have our 4, we're going to glue them all together in a cube by gluing in more springs. You'll notice the holes don't exactly match up, so we may have to put our springs a little bit offset, but that's okay. Apply the glue. We can set that down and let it dry. Just keep checking your springs as they're drying. While they're drying, it's a great time to adjust the spring if needed. Now that we have these 2 done, we can now bond these together. We'd suggest doing it one at a time. The best way to do this is to apply the springs on each one first. We now have our bottom and our top row. Apply a small bit of glue to each spring and we simply sit this one on top. If there ends up little crooked ones like this that you're not happy with, they will come apart if you prise them open hard enough. You can then remove the excess glue. You can then have another go and refix the bond in a better position. You can now go around your cube and just reinforce little bits that you think need some glue. Now we can go around and clean it up by pulling off all the excess glue. And congratulations, you've now finished your jiggly heat. We'll now make a little stand on the bottom by getting 1 carbon atom and 3 electrons and just pop them in anywhere at all. Put it in the corner, just stand it down and twist it around until you find its balance. And congratulations, you now have finished jiggly heat. And we've 15 degrees, and we're turning up to 40 degrees, turning up to 100 degrees, I'm turning up to 200 degrees. Whoa, any more and I'm gonna melt this by actually really breaking bonds due to the energy I am inputting. But when we stop adding energy and reduce the heat, they start to slow down. And just like the river on the mountain, the heat will want to flow from hot to cold. And we can show this by putting another cold object up to it. This absorbs the energy of the faster one and they both find a middle ground. They both find thermal equilibrium. Materials give their energy away out to the air and surrounding surfaces in the form of infrared radiation or heat. Though we feel heat through our molecules in our skin, we can't see it in this form, but our tools can. Overlapping with our next light episode and climate change episodes, I'll hold my hand up against this wall, and the heat of my hand is exciting the atoms and molecules of the wall, making them jiggle faster and faster. And when I release, the molecules say, I'm too hot, and want to give their extra energy away. But only if there is a colder place to send it to. This results in the emission of a hot surface. It's molecules having a dance off, and it's that easy. So just pause the video, remember the 4 basics, and you won't go too far wrong. And that's it for this episode. Next time we will be taking a look at non-living things such as geology and materials, so don't miss it. So thank you for stopping by to watch this video. I've been your host, Paul Burton, and remember, you're not just teaching STEM, you're telling a story, the true story of nature.